Okay, welcome back. Let us see another tutorial example. This is Fourier transform using the properties of Fourier transform. How to find the Fourier transform using the properties of Fourier transform. So our given function is x of t equal to t into e power minus 2t u of t. So let us try to find the Fourier transform by using the properties of Fourier transform. So first of all, uh, we need to know some of the common functions and their Fourier transforms. For example, here in this question, e power minus 2t u of t. Okay, e power minus 2t u of t എന്നുള്ളത്, this is of the form e power minus at u of t എന്നുള്ള ഫോമിലാണ്. സോ അതിൻ്റെ Fourier transform എന്നുള്ളത്, you all know that its Fourier transform is 1 by a plus j omega. So initially ഈ ഒരു കാര്യം നമ്മൾ അറിഞ്ഞിരിക്കണം. സോ അത് സ്പെസിഫിക് ആയിട്ട് സെപ്പറേറ്റ് ആയിട്ട് നമ്മളിവിടെ ചെയ്യുന്നില്ല, ബട്ട് വി തിങ്ക് ദാറ്റ് വി ഓൾറെഡി നോ അബൌട്ട് ഇറ്റ്. ഓക്കെ, സോ ഇ പവർ മൈനസ് എ ടി യു ഓഫ് ടി എന്നുള്ളതിൻ്റെ Fourier transform 1 by a plus j omega ആണ്. സോ അതുകൊണ്ട് you can see e power minus 2t u of t, its Fourier transform will be 1 by here a is to 2 plus j omega. Okay, so this is our x of t and its Fourier transform is our x of omega. So according to the differentiation in frequency property of the Fourier transform, t into x of t is or its Fourier transform is j into d by d omega of x of omega. So x of omega is the Fourier transform of x of t. So x of t യുടെ Fourier transform x of omega ആണെങ്കിൽ t into x of t യുടെ Fourier transform എന്നുള്ളത് j into d by d omega of x of omega ആയിരിക്കും. Okay, അതുകൊണ്ട് ഇവിടെ here in this example we can see t into e power minus 2t u of t. So that is also from t into x of t എന്നുള്ള ഫോമിൽ ആയതുകൊണ്ട്, so we can also use this property here, j into d by d omega of x of omega. So here our x of omega is 1 by 2 plus j omega. അതായത് e power minus 2t u of t എന്നുള്ള ടേമിൻ്റെ Fourier transform, that is 1 by 2 plus j omega ആണ്. So j into d by d omega of 1 by 2 plus j omega. Now we have to find the differentiation of this function. Okay, so this function is of the form u by v. Okay, so u by v യുടെ differentiation നമ്മൾ ചെയ്യുമ്പോൾ, that is u into v into u dash minus u into v dash divided by v square. Okay, that means the denominator square. So denominator j is kept outside, j into d by d omega. So denominator square, that is 2 plus j omega whole square. Then denominator into derivative of the u dash എന്നാണ്, but derivative of the numerator 1 into derivative എന്നുള്ളത്, that is equal to 0, minus numerator into, that is 1 into derivative of the denominator. So that will become derivative of 2 എന്ന് പറയുമ്പോൾ 0 ആണ്, derivative of j omega. Okay, d by d omega of j omega, that is equal to j. Okay, so that will be j, d by d omega of j omega. Okay, so that is nothing but j into d omega by d omega, which is equal to 1. So d by d omega of j omega is nothing but j. So that j is here. So e2 plus j omega into 0 ആണ്, that cancel out ആകും, minus 1 into this one 0 plus j, that is j, so that becomes minus j എന്നാകും. So numerator is in fact minus j, outside ഉള്ള j ഉണ്ട്, j into j, that will become j square. Okay, so minus of j square equal to minus 1 again, so minus into minus 1, that will become plus 1. Numerator has no change, that is 2 plus j omega whole square. So this is our final result. So from this result we can find a general equation, that means if the function is of the form t into e power minus at u of t എന്നാണെങ്കിൽ അതിൻ്റെ Fourier transform എന്നുള്ളത് that will be 1 by a plus j omega whole square ആയിരിക്കും. Here we can see 1 by 2 plus j omega whole square. Okay, so the same way it will be 1 by a plus j omega whole square, that is t into e power minus at u of t. So we already know the Fourier transform of e power minus at u of t, that is 1 by a plus j omega. Then the Fourier transform of t into e power minus at u of t is 1 by a plus j omega whole square. So this is another important result or conclusion that we obtain from this example. Thank you.